Now, on the next, this next slide shows the interpretation of p-value. When you have a p-value of less than 0.01, the result is highly significant. So we have to reject the null hypothesis where we said that there is no difference between the two. So we need to reject it because there's difference. Any p-value of less than 0.01 means there's a significant difference. And when there is significant difference, you must remove any assumption of negation. And null hypothesis is an assumption of negation. So you have to reject the null hypothesis. So if you have anyone that is greater than 0.01, but not more than 0.05, it is still significant, but not as significant as that of less than 0.01. Now, any value greater than 0.05 should be rejected outrightly. Now, on our next slide, we're going to be talking about parametric data analysis for comparative study on SPSS. This simply means parametric are those tests that the three tests here, the student t-test, the Anova, as well as Pearson's correlation. These are the tests we're going to be running on SPSS, and they are parametric because our data obeys the normality test. It passes the normality test and has limited or no outliers. So in that case, you have to go for what? Parametric data analysis. These are the rules you have to obey when you want to run a statistical test. So the first thing we are going to be talking about right now is the t-test. Now, we are going to formulate a data. I'm going to formulate data, on SPSS, just an imaginary data, an imaginary scenario, so to say, just to make the class really understandable and comprehensive. Now, this is a plain sheet of SPSS, as usual. This is a plain sheet of SPSS. Now, I want to code for that Fanta group and the Coke group. What do I do? Don't forget that we just need to click on our variable on the name. What we do is we create a group that will contain two groups. We create a variable that will contain two groups. And how do we do it? Let's name the group. Now, we will need to define the group under values. You click on this right-hand side of the values. It brings this in this small dialog box where we are going to be defining our variable. Now, we will code one for group A, or Coke group. Let's name it group A and add, and we are going to code 2 for group B. Then add. Don't forget that group A and group B, group A is for Coke, and group B is for those who love Fanta. Let's click on OK. And we go back to our variable. We are having 5 variables. You can see how different it is from Excel. Since we are having five individual from the population, yours may be more than that. Excuse me, yours may be more than that. So let's say, let me change this in a way that it will accept numbers. I'll click on A1, don't forget, A1. Now, I'll input the 5 variables. 5 of them are those who love Coke, and we coded Coke with 1. So 1, 2, 3, 4, 5. These are the 5 members who love Coke. And another 5 members who love Fanta. 1, 2, 3, 4, 5. Making 10. You can see it. Making 10 sample size. Now we go back to our variable again. We are going to add the variable for glucose. That is glucose level. I'll just call it GLU. And don't forget that it is numeric, so I don't need to code it. It is a continuous variable. I don't need to code it. We don't code continuous variable. We only code categorical variable. So I have to leave it. Continuous variable, I have to leave it. So I'll go back to data again. And I'll now, don't forget that it's scale. It is a scale. This is a nominal in no particular order, while this is scale because it is a measure. So I'll now go back to my data view. Now my data view, this is where you will now be inputting the value for each parameter. Now for the first person who loves glucose, who loves Coke, let's say he has 4. The next person, 3. Another person, 3 again. Another one, 5. Another one, 4. Yes. Now, for Fanta, 6. 5, 4, 3, 5, 4. You can see how the presentation is different from that of Excel. Now we have our data and we want to run t-tests. Now, why do we say t-tests? Is this data runnable for t-tests? Let's assume it is normally distributed. We've run normality tests, all the 3 normality tests, and it's normally distributed. We've concluded that we want to use parametric analysis, which is either t-test, Anova, or Pearson chi-square. Then we will now go back to that our table, because we now have our dependent variable, which is glucose, and it's a continuous variable. Now note it, our glucose is continuous variable. Now we check our group. Our group grouped into 2 is a categorical variable because we group it into A and B. It is not number, it is categorical. It's just that because we needed to code it into 1 and 2. And anytime we are coding that, it automatically means that variable is a categorical variable. So our dependent variable is continuous variable, while independent variable is a categorical variable. So where do we go now? Let us check the table in on our slide. Now from the table on our slide, yeah, this is the table. Don't forget our dependent variable is continuous. That's glucose level. It is continuous. Yes, this is continuous. Now, which one? Is it Anova or Pearson chi-square? We don't know yet till we say. But our independent variable is categorical, like we said earlier. So it means we are going to be using Anova or t-test. Anova or t-test. But which one do we use? Are we to use Anova or to use t-test? Now, there's where another step comes in. You can only use Anova if you have 3. You can only use Anova if you have more than 2 groups or more than 2 independent variables. I repeat myself. Let me share. Let me go back to the SPSS window. You can only go for Anova if you have 1, 2, and another group, which is 3, more than one group. But in a moment where you have just 2 groups, you have to use t-test. T-test is used to check the difference in mean between 2 groups. I repeat, t-test is used to check the difference in the mean. We are going to find the mean of all these values between the 2 groups. And what are the 2 groups? The 2 groups are group A and group B. Had it been there is another group called group C, then we would say that we want to check the difference in mean across 3 groups. And that will make us to go for Anova. However, since it's just 2 groups, let's go for t-test. Now, how do we run t-test? Now, we have 3 types of t-test. We have 3 types of t-test. But I'm going to be running one of the most used t-tests in research. And the most used t-test in research is the independent sample t-test. The independent sample t-test. Those are the most used t-tests in research. Now, how do we do it? We go to analyze as usual. We always go to analyze. By now, I'm very sure most of you must have known that analyze is one of the key icon in SPSS. So we go to analyze, then scroll down to compare mean, because we want to compare the 2 mean between A and B. Is there a difference in their mean? We are not clicking on mean. We are not clicking on one sample t-test, but we are clicking on independent sample t-test. Now I'll have a click. Now, there's a grouping variable. There's a spot where it says you should what? Put your grouping variable. You put your group, the 2 group we have, so you need to put it first. Secondly, you need to define your grouping because it doesn't know which one is 1 and which one is 2. So you are the one that will define it. So what you do is that group 1 is coded with 1, while group 2 is coded with 2. And you click OK, continue. Secondly, you now put, at this point where it states test variable, excuse me. So you now put what you are testing, what you are, what you are using to differentiate, and that is the dependent variable. So it's glucose. So you just add glucose. And there's not too much we are checking in this, rather than the fact that our confidence interval is 95%. And since it's 95%, the remaining 5% is our 0.05 that made up 5% that we are using as our significant value. If I should change this to 90%, it means, oh, sorry, excuse me, if I change this to 99%, it means our significant benchmark is going to be 0.01, that is 1%. But since it is 5%, I'll leave it as 95% confidence interval. Now, I will click on OK and the output. Now you can see that, mere looking at it physically, you will see that group B have higher mean than group A. But it is not enough statistically for me to just look at it and conclude that yes, there is no difference. And saying that saying of there is no difference, it means I am accepting my null hypothesis. There is no, that negation is for null. So I cannot say that there is no by just mere looking at it. So I need to what? Check the results of my analysis. Then I'll come down to this table. The first thing I'll do is that I'll need to check if my test has passed Levine's test of equality. So the first thing, Levine's test of equality states that this significance that is here must be greater than 0.05. Don't misunderstand. It is different from the other one. For this one, it states that this significance must be greater than 0.05 for you to pick this equal variance assumed to this significant value. This is the t-test p-value, the 2. But sometimes you may have different value. This is 0.95, 0.95. You may have different values sometimes where you don't know which one to choose between this significant. This is the significant. This is the p-value for t-test. Sometimes you may not know which one to choose. To know which one to choose, you need to go to this significance for Levine's test and make sure it is greater than 0.05. If it is greater than 0.05, like this test, you choose the first one, this one, leave the second one. But if it is less than, you choose the second one. However, in this sample, it is greater than 0.05, so we are going to choose this first one. Now, since we are choosing the first one, the value is greater than 0.05. The p-value is greater than 0.05. Now, what do we do next? Should we accept our null hypothesis or reject it? However, let's state our null hypothesis, which states that there is no difference in this mean. The fact that there's just one difference between the mean of group A and group B, it doesn't mean that there is a difference according to null hypothesis. Now, that null hypothesis, should it be accepted or rejected? We check our p-value. Our p-value is now greater than 0.05. If your p-value is greater than 0.05, you were right. Accept your null hypothesis. Accept your null hypothesis. Always start by stating your null hypothesis. Now it states that there is a difference, but it is not enough. Then statistically, we won't say that it is not enough. We will just say that there is no difference. So null hypothesis is stating that there is no difference. And it has been confirmed by the result of the t-test when the p-value was greater than 0.05. That is how to run t-tests. That is how to run t-tests. That's one of the most commonly used t-tests, which is independent t-tests. Now, I want us to go back to our data view and try other types of t-tests. Other types of t-tests. Other types of t-tests. Now, don't forget that t-test is used to measure the difference in mean between two groups, A and B. Now, since it is still t-test, we are still using two groups. Now, let's try another t-test. That's the one sample t-tests. The one sample t-test. Now, in this one sample t-test, instead of we running the two t-tests simultaneously like we've done earlier, we are going to give SPSS a standard. And SPSS will now compare the two groups with the standard, and now tell us if there's a difference between our own gotten value of glucose level and the standard we've given it. You see, this is done in a situation where we don't have a control group, but we want to run comparative study where we have a known control. We already know that, okay, glucose level is not supposed to be more than this. Now let's run it. Analyze, as usual, compare mean, then one sample t-test. Let's click. Now, our test value, let's assume it is 4. And the variable we are testing is glucose. And let's click on OK. You can see. Let us assume that glucose is the single sample for the whole of group A. For the whole of group A, because I don't want to be touching our samples, that's why. Let's assume it is all the sample for group A, all the glucose there. Ordinarily, we'll have, before we can be able to run this kind of test, we are going to clear that of B. We're not going to have group A and B. We are going to have only one group. We are going to have only one group. Maybe group A alone, compare it with that known standard. Then do that of group B, compare it with that known standard. But this is rare in most research of nowadays. It is very rare. The first one, the independent test, is one of the most common. However, it is the same interpretation, only that there's no Levine test of equality in this. So straight up, we will check for the significance, which is also high compared to 4. Compared to 4 as the benchmark, you can see the test value is 4.0, and it means there is no association because it is higher than 0.05. You can see it is higher than 0. This is 0.343. So let's go back to the other type of SPSS, the other type of t-test. Okay. Now, if you are to use the third type of t-test, it is known as the paired sample t-test. In this type of t-test, we are going to have two separate variables. Two separate variables in which is going to assess for us. It means we are going to have two glucose. The glucose, it will be coded like this. The glucose for A and the glucose for B. This is usually different. This is usually not common. And let's assume this is the value for glucose A. Now we are not dealing with this now. We are not dealing with this. We are not dealing with the old one because the imputation is different. So we are not dealing with the old one. We are dealing with this new one. And let's assume this is 5, 5, 5, 6, 7, 8, 7. I'm assuming. I'm just making up data. 4. So let's assume this group A glucose and group B glucose level. These are the values. These are the values. We are not dealing with this now. We have done this to you using this in calculating that of the independent. So now we are calculating the two sample t-test. So now if we are to analyze, compare means and go to paired sample t-test. So we give them the first variable. We give the computer the first variable, especially the first variable, then the second. I'll click OK. Now, I want you to check this value here. We're not dealing with this, we are dealing with this. Now, this SIG23 is the p-value. And you can see it is statistically significant because it is less than 0.05. We have 0.00, so it is less than 0.05, which is statistically significant. We can say that A and B are statistically different. They are statistically different from the data we've just generated. So, but in most cases, you don't need to stress yourself using this type. You just need to use the other independent t-tests. These are the three types of tests that we can use in SPSS for comparative study. Now back to our slide. The next one is Anova. Anova is a very easy statistical test. The only difference is that unlike the other one, the t-test, Anova deals with when you have 3 or more groups. When it is 2 groups, you use t-test. But when it is 3 or more, you use Anova. So let's cite an example. Let's assume there's a group C. I will delete these 2. I will now edit this group in the coding, and I will now add a group C represented with 3. Now let's call it group C. And this group C are those who love water. They don't take anything. Oh, excuse me. Let me edit it very well. Group C. Change. Okay. Now I've edited it. That is why SPSS is very flexible. You can quickly go into all your work and re-edit it and continue. Now if you check, if I should type 3 for another, you can see, let me change this to A. Let me click this A1 first. This 3 should be 3, 3, 3, 3, making 15 threes. Now we have, so let me give glucose just an assumed value. Let's say 2, 2, 3, 3, 4, 2. Okay, it's not part of it. Now we now have 3 levels. Our group is divided into 3. The group A, the group B, and group C. Group C are those who love water. Those who love water. So their glucose level now. So let's now run. If you want to run t-test, you can't run t-test with just 3 levels. So it looks somehow. So it's better you run it with Anova. The same way, all the same way, analyze, compare mean. But this time around, you'll be choosing one way Anova. Now you have to insert the factor. You have to insert the factor, which is group, because the dependent variable is glucose. I repeat, the dependent variable is glucose. So let's insert it. Now, we need to be taking some things into consideration when we are dealing with Anova. The first thing to do is to do your post-hoc tests. Post-hoc tests. Now, it all depends on which one you want to use. But most of the time, I like choosing Shafe. So you've chosen your post-hoc. I'll tell you what the post-hoc test is in our output now. So we can click OK now. Yes, this is Anova. Now this is the output for Anova. You can see in this first test is just telling us the distribution. However, this is where it's telling us the distribution of the 3 groups. Now, this is 0.009. 0.009 is really smaller than 0.005, it means there is a significance among all the three groups. It means group A, group B, and group C is different from each other. There's a difference amongst those three groups. Those of them who like Coke, those who like Fanta, and those who like water. There is difference amongst all three groups. However, we don't know where the difference lies. We don't know whether it is A that is bigger than B significantly, because it states here that it is significant because it is less than 0.05. There's a significant among the three, but we don't know which is significant from each other. Is it A that is significantly different from B, or B is significantly different from C, or otherwise? Now, that is where the post-hoc will tell us insights of what is going on. Now, if you check down, you will see A by this side and B. Then you will now see a significant value, a p-value, sorry. Now, it simply means A and B compared. When you're comparing A versus B, this is the p-value. And if you look at it, it's greater than 0.05, meaning there's no significant difference between A and B. Now, A and C, look at it, it's still 0.209. It is greater than 0.05, meaning there is no significant difference. That means A and B and C are the same thing statistically. Now, we go to B. B and A is the same thing. There is no statistical significant difference. However, the significant difference that was flanking here was between B and C. It means there's difference between those who take Fanta and those who take water. Now, what kind of difference? What kind of difference? That's when you now go to your mean that has been calculated. You must have calculated your mean and now see which one is higher. From this calculation, if you check the mean of, of water, is going to be lower than the mean of Fanta. So it means that Fanta is significantly higher in glucose level than that of water. So that is how to run Anova tests on SPSS. The next thing we are going to be talking about is Pearson's correlation. Pearson's correlation. Now let me go back to our slide, our sheet, or data sheet on SPSS. Now in SPSS, okay, let me go back to our slide and show you something. I want to show us something from that table that we use in making our decision. Now, if you have two continuous variables, and you want to analyze, you are going to be using Pearson's correlation. Now, how do we use Pearson's correlation? We are going to have a different type of data. In this case, in Pearson's correlation, it simply means you want to look at the linearity, or you want to look at the linear association between two continuous variables. For example, this glucose now, I want to check if glucose is going in straight or parallel line with another parameter. For example, weight. Maybe the weight, or yes, let me check the weight, which is going to be continuous. If you remember, weight is going to be a measurable continuous variable. So let's leave it. We don't need to code it. And let's go back to our data view and assume our data. Now, let's assume this is our dependent variable, our independent variable, sorry, our dependent variable. Yes, let's assume glucose is our dependent variable as it has always been. And this weight is independent and it is in continuous variable, such as 50 kg, 48 kg, 60 kg, 70 kg, 65 kg, 50 kg. I'm just assuming 54 kg, 67 kg, 56 kg, 58 kg, 49 kg, 50 kg, 50 kg, 57 kg, 60 kg. Let's assume this is the weight of all participants. Let's assume this is the weight of all participants. Now we want to look at the correlation between glucose and weight. Is glucose increasing as weight is increasing, or it is reducing as weight is reducing? Now we are going to do it on analysis. Now we can do it in two ways. We can do it graphically, and we can also use the normal analysis to do it. Now let me start with the normal analysis. So you start by clicking on Analyze. You start by clicking on Analyze, and you come down to Correlate. You click on Correlate and then Bivariate. Let's click on Bivariate. Now, we will now put the two information, or the two variable that we want to correlate. That's glucose and weight. Then we click on OK. Now, we are concerned about this value. Now we are going to be concerned about two things. The first thing is we are going to be concerned about if it is significant for us to say there is a correlation. Then secondly is that which type of correlation. Is it a positive correlation that goes on a straight line, or a negative correlation that goes inversely? Now, let me tell you what I'm trying to say. Now, the first thing is that it is not significant because it is greater than 0.05. It is not significant. Look at it. You can see this is greater than 0.05. That's significant, greater than 0.05. However, it is a positive correlation. And a positive correlation will go from left to right on a straight line, going upward. Now, let me now plot the graph for you to see, so that you see what I'm talking about. Now, you click on Graphs, Chart Builder, and you now click on Line. You click on Scatter Plots. Scatter. You click on Scatter, not Line. Then you now pick this, drag it to this place. Secondly, you need to bring the glucose on any axis of your choice, whether X or Y, and now bring weights to the other axis. Then you click on OK. It is loading the chart. The chart. Yes. You can see how scattered it is. It is not even on a straight line. However, we can make it to indicate the line of intersection. So what we do is that you double click on this chart, and you now click on this icon, this very small icon. Please, you should pay attention to the icon. This small ribbon here, so you have to click on it. And you now close it. You can see it is positive because it is going from this right hand to this side. If it is negative, it will come the other way, not like this. It will come like this. to come like this. But since it is going from left to right and not the other way, we can say that this is positive, and it is indicative in our output, because if you see the output here, the correlation, the person's correlation coefficient here, there is no negative sign, it is positive sign, so it will go on a positive graph. If it's a negative graph, it will come the other way around. So this is the end of our practice of Pearson's correlation on SPSS. So we have virtually covered the area of parametric analysis as far as SPSS is concerned, and I hope we enjoyed the class, and I wish you luck in all your endeavors. So see you in our next class for the subsequent session. Thank you very much, and have a wonderful day.